Hello, in this video we're going to look at how to transform a beta prime random variable to a beta distribution and vice versa, a beta random variable to a beta prime distribution. And so let's start in with the first one. So let's let x be a beta prime random variable or distribution. So that means f of x is equal to this. X is all, are positive numbers, and alpha and beta are positive also. So here we let y equal x divided by 1 plus x. And my claim is that y is a beta distribution. And so we back solve for x. Also in this, we can solve for x plus 1, which is this. And I do that because it makes substituting in here and here a little easier. So now when we take the derivative of this with respect to y, we get this piece. So now we start substituting in. So f of the gamma functions come straight down. The x is, goes substitutes in here. The x plus 1 substitute in here, and then we have to take it times the absolute value of this. But it's always positive, so we just write it as is. So now the y, there's only one y, so we can keep it alpha, or y to the alpha minus 1. So when we solve that, but then here, this piece gets inverted, and then one of these alphas cancels with one of those alphas. Now this is also in the denominator, so let's raise the top and it becomes plus 2. So then one of those cancels with one of those, and we're left with 1 minus y raised to the beta times 1 minus y raised to the 1, and so that, or to the minus 1. So after the simplification we get this, and y goes from 0 to 1 if you plug it in. So anyway, so that's a beta distribution. Now to go vice versa, now this is also a neat distribution. Well, I've personally never done this. I've read about it, and I'll explain in a second. So let's let x have a beta, be a beta random variable. So that means it has this density. X is between 0 and 1, and then alpha and beta are positive also. So let's let y equal x over 1 minus x. Okay, so why is this significant? Well, if you model the probability of an event or something with, as x, and then x over 1 minus x is odds. So you can actually use a beta prime distribution to model the odds of an event. And while I've never done it, I've read about it. So anyway, so that's one interesting thing about a beta prime distribution. When you use like a beta as a prior in a Bayesian analysis, you can then use a beta prime to model the odds. Okay, so then you can back solve for x, and we get this, and then in this you can kind of manipulate it to get to the 1 minus x, and we do that because it makes substitution a lot easier. The derivative of x with respect to y, you get this 1 plus y minus 1. So when you plug these in, the x is this, and the 1 minus x is this. Now you combine things. So so there's only one y, so that just stays y raised to alpha minus 1. And then you combine these, and you get alpha in the denominator, alpha plus beta minus 2. But this is in the numerator, so when you take it down, the minus 2 and the that becomes a plus 2, and it cancels with those minus 2's, and we get this. Well, and that is a beta prime distribution. And so, well, that's all I have for today. Hopefully you enjoyed it. If you did, please like it and subscribe so you don't miss the next one. Thanks. Bye.